Today, this is what we're talking about. Go plus microservices equals Gokit. I'm not really sure that's true, but let's take it on faith for the moment. My name's Peter. I'm a gopher. There's no gopher emoji, so I've made a golfer, and I've just been doing that. It's pretty close. All right, so what are we talking about? We're talking about microservices, and I guess we all have some idea what that means, but I'm betting we all have kind of wildly different ideas about what that means. So let's wait a second, and let's think about what actually is a microservice, what is a microservice architecture, what does any of this mean? And let's try to build some kind of common context, some kind of foundation. So the question is, like, in terms of definitions, how do you define a microservice? Something that's less than 1,000 lines, or something that's deployed in a Docker container, or something that is written in Node.js or whatever. None of these things I think are really good definitions. I don't think there is a single good definition, but I think there are some things that can point us in the right direction, kind of vaguely. So I've been thinking about this for a long while now, and I've come up with a couple of things, or I found a couple of things that I think make sense. If you think about the idea of size, I think a microservice might be something that, as Fred George puts it, a single programmer can design, implement, deploy, and maintain. So a single person. Dan North kind of gets to the same concept in a different way. He says a microservice is a software that fits in your head. And I think that's a good kind of baseline in terms of the size, how to think about things. Another way is to think about the data that's involved. So a microservice is something that implements a single bounded context in domain-driven design terminology. That's from Martin Fowler, and Sam Newman kind of pushes this idea as well. He's a Microservices ThoughtWorks consultant fellow. Similarly, if you get a bit more concrete, another consultant by the name of Chris Richardson likes to say that a microservice is something that has a single logical database. Often that also means a single physical database, but the point is that it's isolated. It deals with its own data store in a very isolated way. Similarly, I think there's an operational context we can start to think about too. I think a microservice is something that is, in the words of 12-factor. Has anyone heard of 12-factor before? 12factor.net? Cool. If you haven't, check out the website. A lot of interesting things there. But according to these people, a microservice is something that is built and deployed independently. It's stateless. It has state as backing services or as a database. That's, I think, a good sort of lens on it. Chris Richardson again says, operationally, a microservice is something that is addressable through a service discovery system. And I mean that in the broadest sense, DNS or console or something like that. So we're getting at a definition here, kind of. A lot of different ways to look at things. I want to draw another distinction here. This was sort of based on an article I read very recently. When I say microservice today, what I mean is something kind of like this. How many of us are working in an organization that has something we call a monolith? And we're probably trying to hack it down into pieces, right? So that's what I think most people think of when they think of microservices, something on this journey from monolith to microservices. And that means probably the original monolith was something that was kind of CRUD-oriented, like you're dealing with records that get mutated over time, and they have sort of like transactional semantics when you mutate them. Typically, when you're talking about the components in your architecture, it's typically RPC, and it's often implemented in terms of HTTP, though not always. The model is somehow request processing. So a request comes in, you need to do stuff, and then return a response, right? And there's many pieces of technology that you can use to do this sort of thing. Ruby on Rails is the great canonical example. You can do this sort of thing with Java and like Tomcat or Jetty, or if you started more recently, maybe with Spring Boot. If you're in Scala world, there's Ack and Play that lets you implement something like this. So this is what kind of I mean. There's this other thing. It's a little bit different, and people use the term microservice to apply to this as well. Something that's more stream-oriented. Rather than being a request processing sort of messaging pattern, it often is in terms of event sourcing or message processing. This is using technology like Kafka or Kinesis or RabbitMQ, where the idea is you have this like pipeline of data that you need to like process somehow. And maybe you materialize a view over here that serves one particular business case, or do something else over here as a cache or something. This is another super interesting architecture. but it's not what we're going to be talking about today. If you want to learn more about this and this distinction, search Camille Fournier. She just recently did a Medium post that's drawing some distinctions here. So that's what I mean when I say microservices for now. I want to make one important point because I think a lot of people gloss over this important point, and I think it's super critical. So microservices solve organizational problems, but they cause technical problems. And it's important, I think, every time you give a talk about microservices that you say this, because a lot of people think it's the inverse, or that microservices are going to help you out in technical ways, and they really don't. Here's what they do help with. They solve the problem of my team is too large to work effectively on a shared code base. They solve the problem of when individual teams in an organization are blocked on other teams. When they need to ship a feature, they're waiting for something, and they can't make progress. They can help solve the problem of communication overhead becoming too much, so the amount of time you spend in the network effect of communicating decisions between teams and making sure everyone can move forward. And they can also help when you find, as like a product manager, that your velocity of your product is kind of stalled. So this is what microservices kind of evolved to solve, in my opinion, of course. Here are problems that they introduce. When you start doing microservices, you need well-defined business domains in order to have stable APIs, which are important. You can no longer have a shared database, which means if you're doing separate logical databases, you introduce or you stumble over the need for distributed transactions. Search for that, and you'll find a whole bunch of white papers and research papers that give you some sense of how hard that is. Testing becomes really hard as well. I don't think there is even a good answer for how to test a proper microservice architecture product, because there's no sense of even a deployed version. Like, there's no sense of this is the artifact. It's all the artifacts and all the versions simultaneously. It sort of requires a DevOps culture. So you require everyone building a microservice to shepherd it from their laptop through the staging environment through to production and run it there and get paged for it. And that requires sort of cultural changes that you may not be ready for yet in your organization. It requires some concept of a scheduler. Now, that could be totally manual. I could say, I'm going to run this thing here. It could be much more sophisticated, like Kubernetes or Swarm. It requires a concept of addressability, which I mentioned. It requires a much stronger culture of monitoring and instrumentation. You can no longer get by with just tailing your logs or using Nagios and New Relic. That doesn't work at all. And then you start thinking of, well, how do I trace a call through all of these components? I need distributed tracing, and then I need a build pipeline, and then I need security concerns, and it kind of like it's an endless list. And if you were here a couple of months ago, and this meetup, it wasn't here, it was somewhere else, my former colleague Sean Treadway of SoundCloud did a sort of survey of all of the concerns that he noticed whenever he was spinning up a new microservice in SoundCloud. Like, it used to be in the monolith, all this stuff was kind of one-to-one with the monolith, but now he realizes every new service has this sort of suite of secondary concerns that need to be addressed. And he did a survey, and he came up with, in SoundCloud, 40 things that every service needs to have an answer for, from things like, simple things like the name and the programming language and the integration patterns and the transport it talks over, all the way down to like capacity plan, monitoring plan, cost reporting, how it handles logs, how it handles alerts, who gets paged, API documentation, how the source is managed, blah, blah, blah. I won't read them all, but it's a lot of stuff. And now you don't have to worry about this once for your monolith. You have to worry about it n times for every service. And so you can't do this manually. You have to set up processes for all this. Okay. I could talk about all the bad things about microservices for a long time. Maybe that would be an interesting talk in and of itself. But let's say that you are aware of all these costs, and you're still convinced that you want to do microservices in your organization because you need to solve organizational problems. Great. Okay. So you probably don't need microservices. If you're 5 or fewer engineers, you definitely don't. Building an AMI for an EC2 autoscaling group works really, really well for a lot of problems. But okay, let's say that you're convinced you want to do it. All that out of the way. This brings me to the meat of the talk, I guess. Go is a language, I guess it's used here. Anyone using Go, like professionally? Some? A lot? That's cool. Cool, so I won't go too much into the background. I'll give you a little bit about Go from sort of my perspective, especially in this context. Go, in my opinion, is a breath of fresh air from kitchen sink languages like Scala. It has, yeah, thank you. It has, in my opinion, a simple and importantly orthogonal set of features that aren't surprising when they interact. This is very important compared to Node. It's efficient by default compared to dynamic scripting languages like Python and Ruby. It has a predictable runtime behavior, compare against the hotspot tuning mess that is all JVM languages. And it has, I think this is an advantage at least, a familiar heritage, syntax, and programming paradigm compare against Haskell, Elixir, other sort of languages like this. So I think it's great for these reasons and more. I think it's by far the best language for writing servers. And it makes me, well, about a year or two ago, it made me pause and say, well, why aren't more people writing microservices in Go? So this requires a bit of a history lesson. I'll keep it brief. In 2012 at SoundCloud, where I was at the time, we were doing microservices. We called it SOA at the time because it didn't have this catchy name. Teams were picking their favorite languages. Go was very well represented because it was sort of a free-for-all. For a couple of years, the platform advances. We started to consolidate things like the mechanics of deploying, of running stuff. Domain objects needed to be consistent across things. Behaviors needed to be consistent, especially failure modes. The JVM teams, that is the teams who chose JVM languages, sort of coalesced around Scala as their implementation language, and then this thing called Finagle. Does anybody know Finagle? Like, is that familiar? Okay, a couple. So Finagle's sort of like a framework where it handles things like inter-process communication and load balancing and certain other concerns that should be shared across different microservices, different services in the same organization. So they had that. They could use that. They could leverage that. Whereas the Go services kind of had to reinvent everything. And so it turned out the feeling was that Go was missing something. We were missing these transport agnostic libraries to solve RPC problems. We were missing reasonably generic interfaces for service discovery and event streams and logging and things like this. And we were missing a way to enforce organizational standards for all these operational concerns. In general, we wanted and didn't have a way to create and maintain sort of a shared context for building microservices in Go that was interoperable with other teams at the same organization. And I think this is a pattern that you see quite a lot, actually, where a company starts and they sort of like 1,000 languages bloom, right? And then that feels very productive for a while, but then you start to feel like the tension and the interop problems. And then what happens is you tend to coalesce down to like the 2 or 3 environments, frameworks, runtimes that are sort of generally supported in the org as you grow to 50, 100, 200 engineers. And so that's kind of what we felt here. And so, unfortunately, in the business domain, Go kind of lost out. The Scala teams had something they could lean on and leverage and acted sort of like a force multiplier. But the Go teams couldn't justify, in terms of costs, like re-implementing Finagle plus doing all of their own work. So Scala eventually won for business stuff. Go is still heavily used for infrastructure, SRE type work, but not for line of business code, really. And that made me super sad. So what I took from the lesson was that I didn't want this to happen anywhere else. And so enter Gokit. Gokit is, well, let me give you the pitch. It's a way for you to adopt Go in your organization at the business level, allowing you to focus on your business logic, write business domain code in Go, and let Gokit handle all the messy business of common operational infrastructural concerns. Gokit has, as much as possible, very few opinions, and they're held lightly, which means that your infrastructure doesn't have to adapt to run Gokit stuff. Gokit will adapt to your infrastructure as much as possible. So use the databases you want, the components, use the service discovery system, the load balancing strategy you want, the platform, the scheduler, whatever works best for you. Gokit will try to adapt to that as much as it can. So that's kind of the pitch. Gokit is not a framework, so it's not like these other things. If you're familiar with Go, maybe you've heard of Rebel or BGO. Kite is kind of a weird one. Micro is another thing that claims it's a Microservices framework, H2, Go Circuit. These are all kind of all in. They carry, in my opinion, a lot of opinions with them. Gokit is more like Gorilla in that you kind of pick and choose what you need. And as you mature as an organization, you can pick and choose more things from it. Progressive enhancement is a phrase I like. Okay, compare it to, if you know other ecosystems, Finagle from Scala was the initial inspiration. That was from Twitter. I'm not going to be quite as expansive as Finagle is, I think. It just kind of doesn't mesh with the Go philosophy, but basic idea. There's a whole Netflix open source suite of tools that kind of interplay and which are broadly similar goals. Eureka, Hystrix is like a circuit breaker thing, Zool. There's a whole bunch of stuff there. You can go to Netflix OSS and read all about it, but it's all in the JVM. So similar goals there. Spring Boot is also a really good comparison, but that's much more of a framework, a lot of convention. Gokit is much smaller and less opinionated, I would say. Now, Miko, has anyone heard of this before? No? So I look for like microservice framework language. And this keeps popping up, and it seems like a lot of people use it, but I've never heard of it. I've never seen anyone use it. So I don't know. Does anyone know of anything else that might fit this criteria, like in any other language? Like maybe in Ruby, is there something like Finagle? No? If you think of anything, find me after the talk. I'm always curious to expand this list. Here's a list of packages. It's not super interesting. This is more interesting. Philosophy of Gokit. Gokit encourages you to write your programs with no global state. I hope that's not controversial. There's something called Declarative Composition, which I'll kind of describe it a little bit more. Explicit dependencies always, and to treat interfaces as contracts. And there's a lot. This is a very dense list. I'll try to explain what I mean as the talk goes on. The main point I want to make here is that Gokit is really about advancing the practice of software engineering within a Go program. So it sort of trends towards this solid design thing, which is an object-oriented thing. Dave Cheney's going to give a talk about it, a keynote at Golang UK later this week. It's very much in the style of domain-driven design, which I think is also a big part of how microservices are talked about and designed, I hope. And there's this thing called the clean architecture, which is, I think, vaguely similar to hexagonal stuff. It's all kind of like design pattern-y stuff, but there's good stuff here, and Gokit wants to sort of support that and move towards that as much as it can, I guess. Okay, so that's the pitch. That's the philosophy. How does it taste? What does it look like on the page? So what we're going to do today is go through a prototypical microservice. I think it's called the profile service. It's going to deal with user profiles. And we're going to see how, kind of from first principles, Gokit service looks when you just get started and all the things you add into it and how it looks at the end. Hopefully you'll see the advantages to the approach, I hope. So let's say we have some service. And I think this is actually a really nice bit about Go. We can illustrate a service pretty well with just a Go interface. So a profile service is something that can do these two things, post a profile and get a profile. And in real life, it would be a much bigger interface, I guess. But okay, good enough for a little demo. And here's a profile. It's just some piece of data, an ID and a name, and maybe there's a lot of other stuff in there too. Who knows? So this is one core idiom of Gokit, is that your service starts out as an interface with all of the public methods, all of the public RPC methods as methods of the interface. This is important. We'll see why in a little bit. So if you start here, how would you naturally think to turn this into a, let's say, REST-y RPC microservice talking over HTTP? So let's start with that naive implementation. Without any Gokit stuff at all, we're going to have a profile service struct, lowercase p, which is going to implement that interface. And we'll say, just to start, it's just going to be an in-memory data store. So all the profiles are just in a map. So here's a post profile method. Yeah, you're taking the ID. If the profile already exists, that's an error. Otherwise, you write it into the map. Get profile is exactly the same thing. Okay, pretty dumb little implementation. So now let's talk about how we expose this to other people to be consumed, to communicate. One way might be to define a serve HTTP method on the profile service object itself, which turns it into an HTTP handler. In that method, we can do this kind of naive thing where we're switching on the method, the request method. In the case of a post, we're going to decode the body and turn that into the profile. Then we're going to attempt to post it, and if it works, then it works. If it doesn't, it doesn't. Here's the get side. I mean, it's all pretty straightforward stuff. Same thing here. Take the ID from the query parameters, get it out of the memory, and then JSON encode it. And then we're done. Now that the profile service is an HTTP handler, we can pass it to listen and serve. And we can seed it with a little profile here. And just to prove that this is all kind of working, 8080, is it? Local host. Gosh, that's small. 80, and then ID John. Yeah, okay. So, yeah, sure. There's our profile service. Hooray. Kill, close. Hooray. Okay, so there's our microservice, right? Like 2 methods, and it works. And that's fine. Like, okay, you show that to your boss. Hey, we can do profiles now. Does it store to disk? No. Does it do logging? No. Does it do any of this other stuff? No. So let's talk about logging. Logging is something you want right away. Here's how you might try adding logging kind of immediately, kind of naively, right? Like you would go into this serve HTTP method, and then wherever you felt it was appropriate, you would drop a log.printf. And here we have some lines here. We want to log whenever there's an error, so there's 2 logs for the error and then 1 for the success or whatever. Similarly, in the get side, kind of the same deal. And we can log here, and then I won't bother going through all that process again, but yeah, you can see, okay, got some logging going, sure. Okay, so that's fine, but of course we're in this like microservice architecture, and that's not sufficient. We need to instrument our code. Have we all heard of Prometheus, I guess? Because Bjorn came and did a talk here, and he probably talked about it good. If you're not using Prometheus, you should, but you should definitely be using some kind of instrumentation within your application. Here's a little dummy metric. It's a duration, which is like a histogram. And what it's going to do is accept observations, they call. And every time a request comes in, it's going to observe how long the request took in seconds. So we define this variable somewhere. And then we pass it to our little serve HTTP method. And then now we have to augment this serve HTTP again. We have to mark the beginning time. And then before we dump out in each of these branches, we have to observe the time since the beginning. Now, this is sort of a naive implementation. You can imagine ways to clean this up with defers probably. But the point is just to lay this all out pretty explicitly. We've done that here. We've done that here. So, okay, now we've added logging and instrumentation, and our business logic is still kind of clean. You remember the profile service itself, it's still kind of clean. But now our transport code is full of other stuff. It's not just dealing with the conversion of the HTTP domain into the profile service domain. It's littered with all this other stuff, all the stuff I've highlighted here. So Gokit wants to help you separate these concerns. And if you start in the middle, the business logic is like our profile service, and then there's a few layers very close to the business logic where you need to be in the business domain, as I call it. You need to have access to the profile to maybe do metrics based on your business domain or to do analytics. I've registered 20 Michaels today, for example, is something you might be interested in tracking. And then there's this kind of line, right? And above that line, you're no longer in the business domain. You're in sort of the transport domain, or this, I call it here, the Gokit domain. So there's stuff here that has nothing to do with your business logic and has everything to do with RPC stuff, transport stuff. So it's like service connectivity, finding out what other services you need to talk to, where they live, and how to talk to them, and how to maintain connection pools to them maybe. Or safety, like if that service goes down, how do you know to trip the circuit and not send a request there anymore? Metrics, like this endpoint has had a lot of failures recently, maybe we need to look at it. Maybe that machine is dying, maybe that Docker daemon is failing or something. And then once all that stuff's taken care of, at the final layer, at the outermost layer, is the actual transport stuff. So in our case was HTTP, but in your case maybe Thrift or Avro or JSON RPC or Net RPC or something like this. All this stuff is kind of independent of your business logic, which is represented by that interface and its implementation. So this brings us to the concept of a middleware, which I guess we're all pretty familiar with. It would be great to have some kind of single-purpose composable middleware that can do all this sort of stuff. We could have some foo thing that does our business logic, and then we could have a log middleware that had the single responsibility of logging calls according to the transport. Similarly, we could have an instrumenting middleware that did all the instrumenting work, the single responsibility of the instrumenting work. And then we could have other stuff, safety stuff, rate limiters, circuit breakers, all that kind of thing, implemented as middlewares in theory. So in order to get to that happy place, we introduce an abstraction. Let's generalize each of these RPC operations, post profile, get profile, whatever else, as an RPC with a request and a response. We can model RPC methods as what I call an endpoint function that takes a request and returns a response. RPCs can fail, so we need some way to signal failure. And we want to have some way of passing request scoped information through the layers of the onion and back out again. So the actual definition is a tiny bit bigger. It looks like this. Not a big deal. Same idea. Unfortunately, Go doesn't have generics, as we all know. So we got to use this interface thing, which is frowny face. And we can talk more about that later if you want, but that's all I'll say for now. So what we want to do now is convert our profile service into endpoints somehow. One way to do it is to change the profile service methods themselves into endpoints. That is, change post profile from something that takes a profile, something that takes a profile and returns an ID or whatever, into something that matches that endpoint definition. And this would work, right? We could convert our request to a profile and go through all this stuff, and similarly with get. This could be one way. But another way would be to write something like an endpoint constructor, which takes the sort of unaltered base service and then produces endpoints from it. And in this constructor, you do all the work of that translation. So make post profile endpoint takes a profile service. Actually, it should be the interface, not the concrete type. That's a bug in the slide. And then returns an endpoint. And the endpoint is this function that takes the request and returns a response. And all this code does, it has the single responsibility of doing that conversion. So it's a little boilerplate. It's not doing anything complicated. What it allows you to do is keep this clean separation between business and endpoint concerns, domains. It leaves our profile service interface pure. It avoids mixing in the endpoint concerns. Nice. So now that we have a general form of our operation, which is the endpoint, we can layer in value-added stuff, whatever that happens to be, without knowing or caring about the underlying business logic. And so we define this type middleware as a function, which takes an endpoint and returns an endpoint. It's also known as the decorator pattern, I believe. And with this, we can do interesting stuff. So here's a logging middleware, perhaps the simplest one. It doesn't do anything except have some side effect. So a logging middleware is a function that takes the next endpoint and returns an endpoint. The endpoint is a function that takes the context in the request and returns a response and an error. And you see what we do here is we mark the beginning time. We defer a function to log however long it took. And then we just invoke the thing that we've wrapped. So we've basically built a little closure around the next endpoint, and we're doing extra work. I hope this isn't too foreign. It's a pretty common little pattern. That's fine. This request took however long, but what method is it? We don't know. We don't know, based on this information, what method we've actually called. So we need to give more detail to the constructor. So we add, there's lots of ways to do it, actually. This is one that I kind of favor. We add another sort of layer, and now we have this sort of 3 stack, which looks a little silly, actually, but it can stop there. That's the maximum you ever need. In this format, the logging middleware takes a method string, and it returns a middleware. And then it's exactly the same. The middleware is a function that takes an endpoint and returns an endpoint. And the endpoint is exactly like that. So now we've closed over the method, returned a middleware. The middleware closes over the next endpoint and returns an endpoint. And then the endpoint implements the call. So that's the work. And then here's how you wire it in down here. You define your endpoint, initially as nil. And then you call your little endpoint constructor, and that's just unadulterated, right? That's just the pure business logic. And then you have this lovely little pattern where you layer in all of the single responsibility concerns one after the other. And in effect, you're building up this onion where at the core is your business logic, and then each successive layer is just the one thing that you need to do. Log, instrument, rate limit, that sort of thing. Each middleware is exclusively concerned with one task. You can avoid mixing different concerns in the same place. And of course, this makes your code easier to maintain, refactor, and eventually delete. which is what we're all aiming for, I guess. That's not all you can do with middleware. Other endpoint middlewares are circuit breaker. This is something where if you encounter too many failures, you trip the circuit and then you kind of fail fast. That prevents thundering herds and other kind of nefarious problems that can happen in degraded networks or things like this. Rate limiter is very similar. You can enforce a certain number of QPS to a given endpoint before you say, hey, that's enough. So a lot of things you can do at that layer without needing to know more information about the business logic. So that's endpoint middleware. That's sort of the transport layer. If you remember, the drawing at the core was the business logic. Turns out that is defined in terms of this interface, the profile service interface. And it turns out that we can build middlewares around that thing as well. So far, our middleware has been this endpoint deal. But we also have the service interface, which means we can define a service middleware, which is something that takes a profile service and returns a profile service. And this is useful when we want to do stuff in our business domain. Let me show you what that means. Let's say you wanted to know when any Michaels were registered, like we said before. You want to get an alert whenever there's a new Michael on your platform. So you can write an alerting middleware. It's a little struct, as I've done it here. It wraps an existing profile service, and it has this other dependency, which is your alerter. Now, I don't know what that is. Alerter, I guess, is some interface, and maybe it's a database that you write a record into, or maybe it's something that is connected to Twilio and it calls you on your phone or something. The point is that it has this one method called alert right here. And alert, we've got a new Michael. Whenever in a post profile, the name contains the string Michael. Okay, cool. That's like a side effect. That's what the alerting middleware does. Otherwise, it just returns profile service post profile. So it's just like this sort of transparent pass-through. And because we've embedded profile service, we don't need to do anything else. All the other methods get automatically kind of lifted into this alerting middleware. And so alerting middleware is a profile service. It just wraps another profile service. And you wire that into your service declaration in the same way you would wire the endpoint middleware into your endpoint declaration. So you create your profile service. At the center of the onion, you do an in-mem profile service, and then you wrap it with the alerting middleware. Okay, so far we've talked about the business logic. We've talked about transport concerns, endpoint concerns. But we haven't yet, in this model, wired it up to a transport. We haven't made it callable. So let's talk about how we would do that. Gokit comes with a handy HTTP transport, which maps an endpoint to an HTTP handler. This is a constructor. You pass it the endpoint. You pass it a way to decode incoming requests, and then to encode outgoing responses. And that's it. What you get out of it is an HTTP handler. Here's how you would use it with Gorilla. You define a new router. You set your post, and then maybe you have a path, special path, and then you attach the handler, which is exactly this helper object here. And that's kind of it, right? And it turns out that if you do that, then wiring in all these middlewares is, again, very straightforward. Here's your post endpoint. You construct it. Maybe you build a rate limiter. Maybe you do logging, instrumenting, and then you pass it into the new server here. This is your func main, and that's kind of all that it looks like. I mean, I'll run it. And when I load that up, we see all these lovely things. There is Prometheus endpoint that's being posted to and all that stuff. But you can see it's like rate limit exceeded at some point. All this stuff that we want in our microservice, it turns out it's very important. All these concerns, remember, that Sean kind of identified, can be implemented for the most part as middlewares, as single-purpose middlewares that are shareable in your organization in a certain repo that you can import and then just apply. And you don't have to re-implement them for every service. The idea here is to give you a scaffolding, like a framework in a sense, to be able to implement your microservices in a way that allows for code reuse, allows for a uniformity of operational experience, and allows for some kind of structure that respects proper software engineering somehow. So supported transports HTTP. You can do it like plain old RPC. You can do REST stuff. You can do none of the above. We got support for gRPC, which is quite good, much faster if you care about that sort of thing. Thrift if you need to. I don't like Thrift, but I support it, sadly. C is all right. It's pretty easy. At some point in the future, when I get some time, I'm going to do transports for all these messaging systems, message buses. An interesting side effect of this architecture is that if you build your business logic and then you wrap it with all your middlewares, the transport, you can have multiple transports, right? So you can wrap the same the code with multiple transports simultaneously. You run one binary and it can expose different ports. And one of the examples in the repo called add service, it actually exposes ports for each of these transports with the same business logic, all of the same rate limiting, circuit breaking middlewares, and completely usable according to all these different transports. Kind of neat. Shared middleware stacks, just different serialization. Why bother to do all this? Why not just support one thing, have an opinion about supporting only one thing? Well, the reality is your organization has probably already decided on a transport layer that works for you, and you've probably already built some amount of tooling and reporting and culture around that transport layer. My goal here is to make it easy to adopt Go. I want to make it easy to play nice in your infrastructure. You know best. That's kind of my philosophy. And that same philosophy goes not only for transports, but for service discovery, logging infrastructure, orchestration. Where I can not have an opinion, I won't in Gokit. And where I do need to have an opinion, where I need to interface with a service discovery system, for example, I'm going to provide implementations for all the popular ones. So, for example, to do service discovery registration deregistration, I support Zookeeper, etcd, console, DNS SRV, a couple, maybe one other one. Anyway, all the big ones, right? That's important. Okay, I want to take a coda here and talk about distributed tracing. Does anybody know what I mean when I say that? A couple of hands. Cool, good. So distributed tracing is this idea. So let's say this is what's going on. Let's say the client is your iOS app, right? And someone hits a button on your iOS app. And that request goes to your like gateway service, I guess. Okay? Gateway service reads a request. It says, I need to contact, for this request, the user service. Okay? Here's the user service. There I get some information back, and I send it back to the iOS client. And all this is taken, I don't know, 100 milliseconds. Great. What we want to do, probably, when this call graph gets a lot more complicated, is have a way to say, show me all those services that this request touched, and show me sort of a graph of that. Show me exactly this picture, actually, or maybe like as a flame graph of the request as it traversed all these different services. And you can imagine it isn't necessarily this simple. Maybe like goes back here and you realize, oh, we need to actually now hit the search service. So you call another service, it comes back. Now we need to populate a bunch of entities, and it's a bunch of other services. It turns out, once you get to a certain size, this is really important to be able to do. And if you think about it for a second, imagine implementing this. You have to modify every service to accept some kind of token or some kind of request tracing identifier from the incoming request, mutate it somehow, propagate it down to the next set of dependencies that you call, get the responses back. You need to have some idea of a collector that's going to receive these things called spans. And then you need to, there's a bunch of these different collectors. The most popular one is Zipkin. But you need to modify all your services to do this stuff. And if you didn't have like some kind of structure to help you, this could be very tedious indeed. Here's one popular implementation. It produces sequence diagrams that kind of look like this. I wish I used flame charts instead. I find this a lot more intuitive. Anyway, Gokit is, so we've seen all this like scaffolding, all this structure that Gokit gives you. If you have that, then it's actually very simple to wire in another middleware that lets you solve this very hard problem pretty easily. So we have a helper. It's in package tracing. And what it does is it moves these IDs from, for example, HTTP headers into this context object that we've very carefully wired through everywhere. And that's moving this information from the transport domain, from HTTP, into this kind of meta domain in this context domain. Once it's there, we have this other thing, a middleware, that creates spans automatically for you. It's sort of transparent to you. Based on the calls you make, it can return them to you if you need to annotate them with metadata. And then at the end of every request response lifecycle, it automatically emits them to this batch thing, which then emits them to the collector. So, long story short, if you want to support Zipkin, all you have to do is add a middleware to your stack. Here's your endpoint. You just add a new middleware right between instrumenting and logging or whatever, and all this stuff is taken care for you. Imagine trying to do this without the structure. It would be very tricky, I think. That's kind of my cell. That's the Gokit cell. Okay, I don't know how we did for time. I hope there's enough time for Q&A. Yeah, cool. So a quick look back. Microservices are a pain in the ass. They cause a lot of problems, and you probably don't need them. But if you're sure that you do, okay, fine. I think Go is a great language for microservices. Not only is it easy to learn and built, almost purpose-built for applications like this, efficient, rich standard library. It's reasonably expressive, and it has kind of this huge and growing mindshare as we see. Actually, like when I first started writing Go here in Berlin, I think there was about 1 or 2 companies that knew about it, and this was like 4 years ago, maybe. And now if you look for Go jobs in Berlin, there's so many, like probably half of the startups here are using Go in the back end in some way. So this is great. Gokit is my attempt to like fill in the gaps between this like really great language and sort of the business operational infrastructural concerns that microservices demand, with as few opinions as possible, lightly held. Middlewares and this middleware kind of architecture to encode logic with a single responsibility principle. Lots of adapters for common infrastructure components to work well in your infrastructure and bring as few opinions as possible. And just a quick note about sort of the community. We've had kind of slow and steady progress since this whole project started. I guess it's about 2 years old now, or maybe a little less. We have 50 contributors. It's in use at a number of, I think probably about a dozen organizations now, small and big, in different parts. Some people just using the logging, some people using an entire Gokit stack to build their games company, for example. And so it's growing. We're getting a lot of production experience, and I hope it's something that is trustable. That's really what I'm going for. Something that's trustable and that you can sell to your engineering leads and CTOs as, you know, like this thing is legitimate, it's mature, it's driven by experienced people with a level heads, and it's something that we can rely on for the long term. That's what I hope. Okay, and that's it. Thanks very much for listening to my long talk. I really, really hope there's lots of questions, because I said a lot of controversial things. Yes? The question is, do I have a middleware to talk to a database? Do you mean to do what kind of thing? Right. Yeah, so just in terms of general business logic. The answer is no. The way I model that is any interaction your business logic would do with the database is its own domain, right? So if it needs to store records or something, that's like totally up to it. That would be implemented just in the profile service. You have a database handle, and I'm kind of like hands off on that. Whatever database you use, it's completely different access patterns. It's kind of up to you. Gokit's really only about the world of inter-process communication and transport, and to some degree it has opinions about how to design good Go software, and so it eschews globals and uses this kind of very declarative initialization syntax, which means you have a really large func main and no dependency injection in the classic sense. So some opinions like this, but in terms of database access, we don't really have opinions. Yeah. Cool. Anybody else? Yes? Yeah, the question was about logging and how maybe the string identifier post profile wasn't strictly necessary, and that's true. That was sort of a contrived example because I think in reality you would never do a logging middleware at the endpoint layer because indeed you don't have access to this kind of rich information that you actually want to log. In reality, you would probably implement a logging middleware at the service layer. So remember when I had like the Michael has been created or whatever? You probably want to log like the profile ID or the other business concerns. So you'd probably implement logging middleware in that way. The sort of implicit question in your question was, can you attach arbitrary information to like an endpoint, kind of dynamically, I guess? And the answer is no, but this is unfortunately a limit of like the Go like type system rather than anything in Gokit. I could figure out ways around it probably, but yeah, it's like there's always a kind of easier solution just by doing it a slightly different way. So short answer, no. Yeah. Anybody else? Hey, Johan. Hello. The question was about the transport serialization, and in the example I used JSON, but can I use other ones? And yes, this is important. Assuming you use the HTTP transport, then you have kind of free reign over how you take your request and response objects and serialize them to and from the HTTP request and response objects. So in the example, I JSON serialized the profile to the response writer, just as JSON.encode. But I could have just as easily printed it as plain text. I don't know, Gob encoded it. The point is that I had this encode function. Let's see if I can hop back to it. The most exciting part of the talk is finding where the slide is. Wait, yep. Okay, so decode post request, encode post response. These two things. It's just an arbitrary function, and it gets the HTTP request, for example, and it gets your request object, and it's like, figure it out. So you can JSON encode, you can do whatever else. This is for HTTP. Obviously, if you use like Thrift, for example, it has its own ideas about serialization that you have to kind of abide. And so in Thrift, there's like a code generation part, and you use this Thrift IDL, and it kind of generates all the serialization, deserialization format stuff for you. And you tell it if you want framed encoding or like binary encoding, and it's really quite annoying, actually. But it's totally agnostic, I guess, is the answer. Cool. There's a question. Yeah. Yeah, totally. The question is about code generation, and do I see it in the future? And the answer is absolutely yes. There's quite a lot, I will freely admit, there's quite a lot of boilerplate involved in Gokit stuff at present, because a lot of these single-purpose middlewares are indeed just about transporting from one domain to the other, kind of dumb, just like this field goes here, that field goes there. So the next thing I'm working on, my next pull request on the thing, is a so-called KitGen code generation tool, which takes the, for example, profile service interface with all of the parameters and return values and all that stuff. You give it that as input, and it gives as output all of these middlewares, all of the transport bindings, all this stuff to for like a really basic mock service. And this is, I think, like 90% of the headache in getting started. So yeah, absolutely in the future. Yeah, that's the plan. Yes. So the question is about service discovery. How quickly can a service discovery system detect that a new service has come alive or gone away? And this is totally actually dependent on the service discovery system. There's a lot of ways you can do it. One pattern is to do self-registration. That means when the service starts up, one component, like in the func main, is responsible for contacting the service discovery system and saying, I'm alive. And then also when the service dies, it's responsible for telling it, I'm gone. And if that's the way you do things, then it's like milliseconds, right? Just the time it takes to talk to console and then get a response back. If you use DNS, for example, you have to figure that out in the platform itself. You have to have the platform itself, when you schedule something, update a DNS server and say, this thing is now here on this IP, and this is how you can reach it, and probably you have a load balancer or something. And this can take several seconds, potentially. The short answer is there's no short answer. It's all about how your infrastructure works. And Gokit very deliberately doesn't take very many opinions about this. For example, Micro is the other microservice framework that's kind of popular. It has a strong opinion about always deploying your stuff, I believe, don't quote me on this, with a sidecar component that's responsible for like service discovery operations. And in that sense, it dictates certain parts of your infrastructure. You have to do things that way, more or less. Gokit is a bit more agnostic in that regard. That was a bit long-winded. The answer is it depends, I guess. Yeah. Sorry. Yes? The question was about service discovery registration. Can Gokit help? Orchestration. Yeah, sure. The question was about orchestration. Can Gokit help? And again, this is something that Gokit doesn't take any opinion on, really, because Gokit is all about the architecture of the application inside of the application. Once that thing is bundled into a deployable artifact, be it a binary or a container or something, it's kind of up to you and your organization how you want to get that running somewhere. So I'll take this opportunity to point out the website. Here's the website. We have this lovely FAQ. And one of the questions is, how should I deploy Gokit services? And the answer is, it's totally up to you. You can build the binary, SCP it, and run it in place. You can use Packer to create an AMI. You can deploy it in a container onto Kubernetes. Gokit plays nicely in all these environments, and where appropriate, we have infrastructure hooks to interact with things we need to interact with as a service. But Gokit doesn't make any claims about you need to do this or you need to do that. And I think that's actually really important, because what makes natural sense to you in your organization may make absolutely no sense at all to Johan or to me in my organization. I hope that answers the question. Anybody else? Yes. So the question is, Gokit, does Gokit help you find other services and talk to them? And yeah, absolutely. This is the domain of service discovery, right? So when I write service profile service, maybe it has a dependency on user service, for example. I would encode that somehow in my service, and it would depend entirely on how things are done in my org. So if I'm using console, then maybe I would encode that as a set of a console name and a set of tags that would get resolved through console to a set of IPs, right? And so Gokit has adapters for console that allow me to just specify name plus tags, and what I get back out of it is a load balance, a so-called client-side load balance pool of connections that Gokit maintains. And so now the user service is just this interface that I can just call, right? And if the user service gives me a Go client library, I can construct it around that endpoint. If it doesn't, I have to make my HTTP request manually. That's also totally possible. So that's one model of service discovery where I'm constructing the client-side load balancing. Client-side load balancing is the pattern. Another model is there is this load balancer at maybe it's loadbalancer.internal.com, or maybe it's on every host, on localhost. I can rely on the fact that there's a load balancer on port, whatever the HA proxy port is. And then my contract is I can always talk to localhost and then / users. And maybe in my organization, that's how things are set up. In which case, you don't need any of that client-side load balancing stuff. You just talk to it that way. So yeah, this is these are all really interesting questions, because they really reveal how much of this microservice world is so poorly defined. Because what is totally intuitive for you, how do I find my dependency, might be for somebody else completely an irrelevant question, because what do you mean user service? It's always at users.weave.local, the DNS name. Of course that's how it works. And then, or maybe someone else's, it's always on my HA proxy. There's just so many ways to do things, and none of them are, at least at this point in the microservices ecosystem in the world, none of them are right? It's all depending on where you are as an organization, how many people you are, what cultural context you have. Again, super long-winded. Did that answer the question? Ish? Cool. All right.